So part C of the question says block 3 of mass M3 is added to the system as shown below. There is no friction between block 3 and the table. And then it says indicate whether the magnitude of the acceleration of block 2 is now larger, smaller, or the same as in the original 2-block system. Explain how you arrived at your answer. So this part of the question is actually very, very cool. Intuitively, we can say, obviously, adding a mass to the system is going to decrease the acceleration. But now here I'm going to be showing to you mathematically how everything is confirmed as well. So here I drew free body diagrams of the 3 blocks. The catch is because we have the system moving this way, again moving this way, we have 3 different tensions. So I'm going to label this by T1, let's say. I'm going to label this is also T1 because this is where it's connected from between 3 and 2. This is one string. And this is another string, which I'm going to label it by T2. So this is another string, which connects block 1 and 3. And so what happens is the free body diagram for these 3 blocks are being given like so, and then we need to write down Newton's second law for each and every one of them. Starting, let's say, from block number 1, we know the system moves to the right. So that being said, T2 is bigger than M1G, so I'm going to write that first. The second block is block number 3. We know the system moves to the right, so that means T1 is bigger than T2. The third one is, the third block is block number 2. System is moving to the, like, downward essentially. So M2G minus T1 equals M2A. And now simply adding all of them together, you'll see that these 2 cancel out. These 2 cancel out. I'm going to end up with this, that we used to have it in part B as well. But now here, rather than M1 plus M2, we have an extra mass to consider, which means that the acceleration, if you want to solve for the acceleration, is going to be M2 minus M1 times G over M1 plus M2 plus M3. So as you can see, and as you can compare with what we had before in part B we had M1 plus M2 in the denominator. Now the denominator has increased, which means that the whole fraction is going to decrease. So the acceleration in part C is going to be smaller than the acceleration in part B, and you can very easily figure it out through just comparing the formula. The numerators are the same in both formulas, but the denominator for part C is larger than part B, which makes the whole acceleration smaller. And also intuitively, you know that if you're adding a block of M3 to the system, it kind of like slows down the system a little bit. So that just wraps up the question. Bye.